Thanks so much for introduction. So, guys, let me take you back to the lens of low productive agriculture systems and how the phenotyping technologies could possibly help these to be more productive. So the structure of this presentation is as follows. First, we will look at the generic principles, which some of them my colleagues were already talking about, so we will dig tiny bit of deeper. Then we look at the hopefully successful case study for the technology integrations in a case of peanut breeding team in South Asia, how we created impact using the technologies, but importantly, what are also constraints which we encountered on the way. And of course, this session is about Africa, so we will look at what is going on with these efforts in Africa and what could be the ways forward. So the general principles. I was a little bit wondering why nobody really talked about phenotyping of environments, because for me that's key, absolutely basic part of the phenotyping. And then I realized that maybe this topic might need a bit more attention. So crop growth models are here to basically help us to smartly evaluate the situation in the agriculture production systems at scale, facilitate their quantitative analysis, and also hopefully design them in a better way. So what these crop growth models are, those are the system of mathematical algorithms which take a static input. This is hopefully the pointer, which take the static input on a climate, crop, soil, and crop management, and transform these static input into the dynamics of the crop interaction with those environmental conditions across the required time and scale. And then we can perform further analysis. So not only that it helps us to understand the constraints and opportunities in a given system, but importantly for this audience, this is a very powerful tool, how to design the ideotypes, the set of genetic features or traits, let me say, which when they are combined, they could basically stabilize or optimize the production in different systems. And what you see in this picture and what I wanted to stress on, that the ideotype will be different for different contexts. Not only that, not really many people talked about the management, but crop management is a huge part of system optimization. So we can actually virtually combine the exercise of genetic combinations with the management combinations. And then, of course, we come to our beloved topic. So we can play in silico on the computers, of course, but we can design the ideotypes, but then eventually we can land up on the ground. So in our case, in a breeding program, for example, and there, of course, breeders like to make millions of crosses. They spit out the filial generations in a rate of thousands. However, what do we have in the farmers' fields? Those are few genotypes, isn't it? So how do we really get from those thousands of lines to those which are having higher potential to perform in those target environments? And being adopted is precisely the challenge for high throughput phenotyping systems. Straight from the beginning, and seeing the presentations which have been given before, I want to stress or point you to this direction. I believe that it's really time that we as a community put a big thought on how do we generate value from all those terabytes of data which we are generating. Each run, we run our sophisticated platforms for particular end users. So we are getting just the little announcement on my end. So we are getting, as a little community, a bit better organized to help and support various kind of end users in our realm, to help them to basically generate the value out of the data which they produce, because many times they are not lucky enough to have all the components which it takes to successfully generate impact out of their data. So when we were analyzing all these stakeholders' needs, usually we land up in three domains. The first one deals with data management. Some of the colleagues mentioned FAIR principles. Now the more recent even idea is to adhere to digital responsibility goals. I think Dr. Bhaskar was talking about it. The next part is really how do we translate the signal from all those sensors into the features which are extractable and which generate the value which the end user needs to use. And then, of course, scaling up that knowledge from these two up to across the time and space in the agroeconomic systems. Economic, please note it. Not many people talked about the economics, but this is something which actually give us a go or no in the end with a particular technology and value proposition. So now let's look at low productive systems in Asia in our breeding team. What is happening there? How did we generate the impact there? So first, exercise of environmental analysis. So this little few colors on the map is actually 2 terabytes of data which you are looking at of the system analysis exercise, which shows the 85% of peanut production systems in India, and those different colors are actually homogeneous environments into which we can target our interventions. So they tell us about the level of heterogeneity of the systems, but they also tell us what are the limitations, what are the opportunities to drive the production in these systems. Next one. 20 terabytes of data, 50,000 simulation in each grid, which are the combinations of different genetic features, different management features across many years of data and across the future scenarios, which then help us to prioritize which kind of genetics and management combinations are actually required to design the system more resiliently and towards the more stable production. So I just simplified this exercise for you dramatically, but something what we really need to squeeze out of these terabytes is the ideotype, which we can then produce in a real breeding system. So this ugly table here on the right side is a simplification of what kind of phenotype you actually need for a particular environmental cluster. In this case, it's Western Rajasthan. You see that there is irrigation management and there is also rainfed management of these systems. So here on the left of this table, what you see is there are the traits in a very simplified way, which are either related to plant vigor or water-saving traits, which our colleagues talked about already. So you see here on this right side of the table the importance of each trait for that particular system. So of course, vigor is important, but I want to drive your attention to this one. So this tells us that the importance of water-saving traits in a rain-fed system is so much more. So in the case, breeders' mass selection for these traits, they hugely destabilize these production systems. That is what this number tells us. So now, okay, we have been playing with terabytes in silico. How do we enter the realm of breeders which have to deal with screening of those thousands of lines in real life? So we have got several systems which help us to approach the ideotype. One of them is LisyScan, and you see that that has been built to actually cater for the needs of breeding programs. So our throughput is we can analyze 5,000 breeding clients in a few weeks assay for the traits which are related to plant vigor, plant structure, plant function, plant health. And surprise, surprise, those are exactly the traits. Actually, the system has been designed that way from the beginning to cater, to be able to approach and measure the traits which are the important components for the genetic makeup for the crops which need to be created to perform in those target agroecosystems. So next one, let's look again, very, very simplified way how we can see the breeding programs. So peanut breeding, some crosses at the beginning, which I was talking about. And then we have the thousands and thousands of lines, and we are selecting as we are approaching the field trials. So in the first part, it is not one technology, it's a technology bundle, which help us at the early in the generation advancement to saturate the selections with the phenotypes, which help us to stabilize the production in those target environments. And Moez was already talking about, which is so important not to neglect. The moment we approach multi-location trials, we need to really screen very efficiently for the post-harvest qualities. So there are so many smart technology minds around this system which helped us to make this to come true. And now you can see this is one of the very few examples which we have in low-income countries where we actually have the fully technology advanced breeding pipelines. I hope. Otherwise, prove me wrong later. How do we measure success? No, maybe I can throw on you these beautiful pictures and ideas, but in the end, we need to measure the way whether we are making progress or whether we are making harm to the already existing process. So Moez was already talking about, and I was happy to hear someone talked about the genetic gain. So this is the pampered formula used by breeders to measure the success of their breeding program. It's the function of the selection intensity, selection accuracy, heritability, and the speed of generation advancement. Of course, time and cost of the evaluation when we go from one generation to another matters immensely. This is a little bit busy, but you can read it later if you want. So this three-layered approach at the beginning has helped us to more effectively select for environmental adaptations of the crops for that particular context. And in the second half, we have tremendously advanced the speed of the post-harvest evaluation and also reduced its cost. I didn't dare to put numbers, guys, but the first idea is that we are 3 times faster in the second half for post-harvest evaluation with the technology, and we were able to save around at least $25,000 per breeding cycle, which is not much, but it's at least something, and it leaves us in the green numbers. So constraint which we encounter and which we overcame, actually relevance of phenotype. I think that is something what the society have to hear every time. So what we have developed for peanuts? So we have a system how to validate the relevance of phenotype and phenotypic components in silico. We are putting a lot of effort to validate the traits functionally. So you see they need to be related to the agronomic performance in that given context. And we also need to validate them genetically. So if we have a colocalization of the trait with the yield, so then that is indication that those two are related. I was talking about the data that was a huge trouble for us to generate the value from the data, especially in this complicated system of phenotyping technologies. And now we are organizing ourselves even better to approach this problem much more effectively. And this is a big struggle. I don't want to go into the details, but I hope that everyone knows what I'm talking about here. So now that is why we are here in this session. What do we have for Africa? So for Africa, if we want to approach it in the same way which worked in much easier playground in South Asia, and I'm stressing much easier in South Asia than even in Africa. So development of model tools. So we wanted to use the same models which worked for us. And surprise, surprise, they did not work. They did not cater for the phenotype, which is the key adaptation in those lands. And we had to work really hard several years with the University of Queensland folks to make it relevantly working for those systems. And we succeeded. So after a lot of struggle with the data availability, I don't know whoever worked in this context, then you know how big struggle is to get the quality of the data to use in your analytics, especially this kind. So after quite some of a struggle and creativity, we were able to analyze the production systems, for example, here for Mali for sorghum. So now we are looking at this enormous exercise of system design, which is just fresh from oven. So I don't really have some extra super hypothesis at the moment. This is Mali there. It's 100,000 of simulations per grid, looking at the combination of very different genetics features of sorghum and very different management practices, which we interviewed for the breeders and which we have encountered on the ground. So, so here you already see that there is quite surprising trend, which is reversing whether we are in shallow soils or deeper soils. But I hope that in the next opportunity, I will have more information for you what the ideotype of sorghum for these West and Central Africa lands might be looking like. And now our beloved phenotyping, sorghum BCNAM, 5,000 lines generated to enhance production across the African continent. So what we did, the only thing which we can do at the moment, we screened them in the field in multi-location trials. We imported them to ICRISAT in India. We screened them in our high-throughput phenotyping systems. And it's amazing. We are getting quite a lot of colocalization of QTLs of the traits, which are measured. Those are those usual suspect traits, which we can discuss later on, which are measured in our high-throughput system with the agronomic features, which are measured out there in the field. So, yeah, but first thing, which I again want to stress for, those QTLs are, and their effect depends on the environment where you plant that particular plant. And you see that the pattern looks very similar from our modeling exercise. So the next, this is with, that previous example was with Siraj, this one is with IRD. So again, this is the case of sorghum diversity panel, some 400 genotypes, nothing that big, which we have screened along with our partners in Senegal, because we designed even these manual ways how we can phenotype when we cannot really look at these automated ways. And we are now exploring the same thing, the colocalization. Is the genetics common between those two systems and how it could be possibly used? If you would ask me, this is going to be very beautiful publication, but is that really useful? Publication is not what we aim for here. But we want to help, in this case, our breeders sitting out there in Senegal, Mali, asking us for years, what do you have for us to offer? And this is, in my humble opinion, overkill, sorry. We cannot be importing in that breeding pipeline those thousands of the lines every year to cater for it. We can validate certainly the traits which are important, but not sure whether this could work on a regular basis. So I wanted to share with you and put a little bit of challenge on the audience because not many people talked about this. Oh, constraints first. Sorry, before that stuff which cannot let me sleep nowadays, I will talk about the constraints. So what do we have? The constraints are very similar as we have in South Asia, but I want to underline several of those. One is data availability. We struggled there. I'm sorry to say, but the best data sets for our modeling, for example, for Africa, comes from University of Queensland. Is it really all right? I'm not sure. Michel talked about community development and networking. I believe that's the need of the hour, really. If we are to translate these technologies into some value for people out there, we really need to do much better on this front. Cost, transferability, and maintenance of phenotyping technology underlined here. It should come actually the first. We talked about it before. So this is the thing which doesn't make me to sleep. So everyone knows about miniaturization and mobilization of all these phenotypic technologies. more and more we see papers like this about these wearable sensors which you can stick on the plant and measure whatsoever. They are highly affordable. Now the question is, are they accurate for our purpose? Are they representative of what we want to measure? Are they relevant to that particular context? And even better, this comes from my neighborhood, University of Palackého Olomouc. These smart guys, material chemistry, nanotechnologies, my goodness. When I heard this first, I thought, what? What? Not possible. So these guys, they are making this graphene baseline, and they stick some ligands, some molecules on it, which creates the electrical signals whatsoever. Then they make it into ink. They put it into printer, they print it, and then you have a sensor which can measure exactly what you would, based on how you design that ligand. And there are certainly the interesting things which they are already being measured in the realm of human, in the realm of animals. Now we are actually looking together with those smart engineers and a little bit of biological insight what needs to be done. For example, in Africa, how we could possibly use this. Because look at that, they are able to print it with the rate of 10 cents per sensor. Highly affordable, very much accurate. I have seen those, well, I don't have them here for plants, but they are really, really accurate when we design them for particular purpose. Now the question is to do the biological functional validations. Can they really measure the traits which we yet ponder what they are for those, to help stabilize those production systems in the African context or wherever for that matter? And are they representative? Those usually talk about single point measurements. So that's something which needs to be also taken in account. Deep breath, you are not sleeping, hopefully. And I still have 3 minutes to torture you. So but anyways, I will go for the summary. So phenotechnology for breeding. We have one of the success case, I hope success case. If you believe it's not success case, please come to me. We will discuss further how to make it better. One thing, context matters. Crop growth models are here to analyze the context where our staple foods are growing and how to design those systems better, including the ideotypes, which then the phenotyping technologies can really help us to generate them in a real life. PhenoTech bundles, it's for at least in our case, it was not a single technology which helped us to evaluate the effect of in the breeding program of these particular systems. And if we claim that we can do better with technology, we have to measure in some way whether we are actually doing better with these technology-assisted processes. Yes. And for Africa, yes, let's put our heads together and look at how to build the community, how to build the relevant tools and methods, and how to deal relevantly with those data, and better together than alone. So what I really want to thank is our beloved trusted partners, which never let us to fight alone on these front fight of challenges which our humanity is facing, because that is what we are here for. So to make our world better, I hope. So thanks to everyone, and I hope I did not forget many. And if there is questions, you can either ask now or write me email.
Thank you, Jana. Any questions for Jana?
Everyone is, oh no. Michel, don't scare me.
Not a scary question. Thank you, Jana, for an interesting presentation. I have a question for you. You presented the graphene type sensors. What is your views? What are your views on that? And how do you think we can leverage that in a way that makes sense?
That's precisely why we need to rewrite that API to figure that out together. Because this looks like, I don't know, maybe I'm too enthusiastic as usual. maybe this is the way forward. This is really disturbing my safe space. It is like something beyond what I would even accept to talk about a few years back, but now we have this challenge of low-cost phenotyping, smart guys, which can really do the miracles in this realm. So let's explore what we could do.
We have time for another question, maybe? Yeah.
Yeah, cool talk. Just coming back to the discussion we had yesterday, so we're here out in the open. I think
I don't remember most of it, sorry.
There was some cocoa water involved in it. The point was that you have a very strong network through ICRISAT, and that we discussed a bit like, should we do a stakeholder analysis in Africa? Should we figure out in which countries is happening what, more as an analysis, like a study? I think it's the other way around, that you already know the people that are potentially interested, and we should not focus on the stakeholders or the needs of the individual institutes, but focus on the individual persons. And that a network like this is not built of companies and institutes, but it's actually built of people. Maybe you can explain your perspective on this.
It absolutely resonates with me. It's all about people, it's all about trust, it's all about community and communication. And that is why yesterday I was so much pushing about the stakeholders analysis, and I'm very careful when to say that I know what is needed. Of course, I know few networks, few systems there, but it's same like what Michel said. We really need to do this somehow to understand systematically. And sorry, guys, I will repeat myself. Biologists cannot do the socio-economic studies. We need even specialists to look at what community is built of, what their needs are, the way how to communicate with them efficiently. So we can definitely, there is a beginning points where to start from, which organizations, which partners, but then that needs to be systematically accelerated with the specialists which know how to do that.